As you can see, I just got too excited. I just started doing the whole video. And I was like, I should probably record before I write anymore. We're going to talk about solving triangles with inverses, okay? So let's say I give you a right triangle like this, and I ask you to solve it. Remember what this word means? Solving a triangle means find all the angles. I'll actually write out the word. Find all the angles and all the sides, their measurements. All right. And let's say I give you this triangle and I tell you that this side is 9, this side is 12. Well, first off, we can find this other side with a Pythagorean theorem. All right. Well, let's do that later. Let's just find an angle right now. Let's call this angle over here theta. Maybe this angle over here phi. Remember, I'm writing it kind of small, but that's what I'm trying to write. You could call it something else as well, but Greek letters are very common for angles, specifically those Greek letters. So how do I find a trig function that relates these three things together? Well, it's the adjacent in the hypotenuse, SOHCAHTOA. That's a cosine. So cosine of theta is equal to 9 over 12. Oh, so cosine of theta, oh, I'm getting excited. Cosine of theta reduces to 3/4. So what is theta? I don't know. Let's use an inverse trig function, right? If cosine of theta is equal to 3/4, then the inverse cosine of 3/4 equals theta. And that goes back to the first video, right? The input of cosine becomes the output of inverse cosine, and the output of cosine becomes the input of inverse cosine. Another way that you can think about this is you can think of, oh, let's take inverse cosine of both sides. If we do that, this left-hand side cancels out because theta is in the range of inverse cosine. Theta is between 0 and pi over 2, so they cancel out. Sometimes they don't always cancel out. We'll talk about that in the next video. But here they're going to cancel out and just left with theta, which is what we have. Okay? There's a couple ways of thinking about how we get to this point. The important thing is that we do get to this point and get an approximation for theta. This is no special triangle. It's impossible to evaluate this exactly. What we're going to do is find out what is the inverse cosine, the arc cosine of 3/4. And it's approximately 0.7227. Use 4 decimal places for these angles when possible. All right, so we do that, and that's theta. Great. Part of our answer, we could even kind of add it over here, right? This theta is 0.7227. I did not give myself enough room for this. Let's not add that. If we drew the triangle bigger, yeah, we'd fill it in right there. And then we can do the same thing for phi, right? I want to do this angle, this side and this side. We'll look at the sine of phi. Because the sine of phi, right, is opposite over hypotenuse, so it's also 9/12. So by an exact similar logic, phi is going to be the arcsine of 3/4, which we can approximate with the same calculator. Change arc sine from arc cosine, and we'll get 0.8481. As an approximation for phi. So now we know this angle, we know this angle, we definitely know this angle, that's 90 degrees, pi over 2. We're just missing this side right here. Pythagorean theorem. We can call this x. Well then, 9 squared plus x squared equals 12 squared. Solve this out, 81 plus x squared equals 144. Subtract 81 from both sides. Should get that x squared is 63. If I did my math correctly. And so we should get that x is approximately plus or minus the square root of 63. We're not going to have a negative length on this triangle, so we're just going to use the positive. This does simplify. This is 9 times 7. This does simplify to 3 root 7. This is the exact answer for x. Or you could use a decimal approximation as well. Normally, I say exact answers, but because we have plenty of other decimal approximations, I'll take it here too. But this is our simplified exact answer. And that is a solved triangle right here. Okay? Pythagorean theorem and inverse trig. Let's do part B. Let's draw a big triangle so I can actually fill in the blanks. Triangle not drawn to scale. Big triangle, and let's say the hypotenuse is 10 and this is 6. Again, let's do the same thing where we call this angle over here, let's call this theta. Let's call this angle up here phi. We can actually evaluate all these things. So pause the video, try to use the earlier example to work this out yourself, and then let's see if we get the same thing. Great. Hopefully you did it. So we want to relate these three things. We're going to do that with sine, SOHCAHTOA. Sine is opposite over hypotenuse. The sine of theta is equal to 6/10. The sine of theta, that reduces to 3/5. Oh, this is a special triangle. Not the special triangle that helps us get exact trig functions, but it is a special triangle. Take the inverse sine of both sides to get that theta is equal to inverse sine of 3/5. And again, the reason we can do that is because this angle is in the range of arc sine. This angle is any triangle, any acute triangle, so any right triangle will have this be the case. All right, so type that into a calculator. Inverse sine of 3/5. Oh, it's really simple. We almost already have it. There we go. 0.6435. And we could write that here. 0.6435. And again, this is an angle. It doesn't look like an angle, but it is an angle, right? This is radians. If you wanted to convert this to degrees, you could, right? This is radians, so multiply it by 180 divided by pi. That's about 37 degrees. You don't have to. I'll take either form. You could, though, because 0.64 radians is a little hard to visualize, I think, even if you're really good with radians. But 37 degrees is much easier to visualize. And do the same thing for phi. So the cosine of phi is equal to 6/10. Do the same exact logic. You're going to get that phi is arc cosine or inverse cosine, same thing, of 3/5. We can approximate that. Arc cosine of 3/5 is about 0.9273. Or, likewise, we could convert this to degrees as well if we wanted. Multiply by 180, divide by pi. It's about 53 degrees. Now, hopefully, you're saying to yourself, why is Jason doing so much work? Well, I'll be honest, I wasn't paying attention. But we are doing way more work than we have to. It's good to check our answer, and it's good to get more practice using inverse functions. But right, once we find theta, we immediately know what phi is. They're complementary angles, right? Theta plus phi adds up to 90 degrees, or pi over 2 radians. All right, so you could also have been doing this to find your second angle. Once you know 2 angles of a triangle, you always know the third angle. So we've been doing a little bit extra work. All right. But extra inverse trig practice. All right. Last thing we need to do is we need to find out what our x value is. Let's do that in green. Well, again, x squared plus 6 squared equals 10 squared. Simplify that out. Subtract 36. Take the square root. X is equal to 8. And there we go, just like that. We have solved the triangle. Let me know if you have any questions, and good luck. I don't think there's very many of these on the homework.